Assalamualaikum warahmatullahi wabarakatuh. Today, I am Nurnisa binti Dalim, together with three of my friends, which is Siti Nur Azimah, Afif Aiman, and Siti Nuraida, will present our research topic, which is life cycle assessment about glass bottle. For introduction, as we know, environmental sustainability is about ecological balance. Today, we can see that humans themselves have become a carbonized planet, which leads to global climate change. As we know, climate change can occur due to human action as well as naturally. But most of this climate change is caused by humans themselves. This has affected the earth, such as warming the atmosphere, land, and ocean. So, today we can see many organizations that have the same goal to protect the Earth's ecosystem from harm to future generations. So, we conducted the study to see the extent to which glass bottle can affect the environment, whether good or bad. As we know, glass bottle consists of various sizes and are used in food seasoning, such as chili sauce, soy sauce, cosmetic items such as perfume. To produce this glass bottle requires a large amount of energy, and to recycle it also requires a lot of energy. Plastic recycling items are easy to find recycling place, but for glass not all place will accept it. So with this LCA, we can help identify areas where environmental improvement can be made and inform sustainable decision making by providing a comprehensive view of the environmental consequences of certain action or products. First, reduce, reuse, recycle to minimize waste generation by practicing the three principles of reduction, reuse, and recycling in daily activities. Next, for goal and scope. The purpose of the study is the product of glass bottles, which is to see global warming potential. In life cycle assessment, the goal refers to the overarching objective or purpose of conducting the assessment. It defines why the study is being undertaken and what specific aspects of the product or process life cycle are being evaluated for their environmental impacts. The scope of this LCA is cradle to cradle. Scope refers to the boundaries set for the analysis. It defines the extent of the system being studied, including the life cycle stage, processes, and input and output considered. LCA can have different scope. Clear delimitation of scope is crucial for accurate and meaningful assessment of environmental impact. Next, for functional and functional unit. The equivalent amount of carbon dioxide produced from the manufacture of 1 million 1 liter glass bottle. The functional unit for this project is defined as the manufacture of 1 million 1 liter packaging. The scope of this LCA is from cradle to cradle. For the product, this included all steps from the extraction and transportation of raw material and fuel, followed by all conversion steps until the glass bottle is delivered to the customer and used for use as raw material. The global warming potential GWP. It is important to assess the entire life cycle, including raw material extraction, production, transport, use, and end of life disposal. Glass, despite having a lower environmental impact in terms of raw material extraction, may experience higher transport emission due to its weight. Next, for system boundary and assumption. The entire process of container material production, from raw material extraction to manufacturing the materials used in the container, is considered. The transfer of empty container from the manufacturer to the milk filling facility is part of the process. The analysis includes the transportation of filled container from the milk factory to a distribution center, and the subsequent step to retails is not considered due to influence data and the assumption that is negligible compared to upstream transportation. The distance between the mentioned locations are as follows. Glass bottle production to milk filling station is 100 km. Milk filling station to distribution center is 100 km. Distribution center to recycling center is 100 km. It is assumed that 70% of glass bottles are recycled and the rest end up is incinerated. The process taking place in the recycling center is not included in the system boundary. The rest 13% is incinerated. The study used average data rather than marginal data. At the end of life, system expansion have been used as far as possible in order to avoid allocation.
Life cycle inventory. So life cycle inventory (LCI) is a crucial component of life cycle assessment (LCA), which quantify the environmental impact associated with a product or process throughout its entire life cycle. So we use the raw material extraction to end of life disposal. So this inventory usually include the consumption of resource such as silica sand, soda ash, limestone, energy and others during the extraction and transportation. Production process require melting the raw material in a furnace, forming the molten glass into a bottle with a mold, then gilding the bottle to shine it. Transporting finished bottle to distribution center and then to consumer. During the use phase, elements such as bottle washing and reuse, as well as disposal after single use, add to the overall inventory. So, for the potential for recycling at the end of the bottle life cycle, involve further input for the collection, transport, and processing of recycled glass. Mass balance of material input and output. For the first, the material loss in melting was caused by decomposition of substances due to high heat exposure. And then after the process was formed, some material were recycled to be used in the batching process as domestic cullet. This applies to after the process inspection. And the final mass of 1 million glass bottle will then be transported to the milk filling factory where milk filling process takes place. And after the use phase of the glass bottle, around 70% of cullet, which is recyclable glass, is used as an external cullet in the batching process. The rest end up as a waste to be incinerated, and this process is called waste incineration.
LCIA. LCIA, which is a short form for the life cycle impact assessment, evaluate the environmental consequence of product, process or service. Throughout its life cycle, the assessment include identifying, quantifying, evaluating environmental costs and benefit at different stages, from resource extraction and production to usage and disposal. A few key factors considered in LCIA include energy consumption, greenhouse gas emission, water use, land use, toxicity, and other environmental indicators. The goal for this assessment is to inform decisions that reduce environmental impact and promote sustainability. LCIA provides a comprehensive understanding of the environmental footprint of a product or process according to the state of the process. According to this table, it can be seen that combustion of carbon dioxide from melting process has the highest amount of carbon dioxide, which is 101727 mg. Meanwhile, indirect carbon dioxide for surface treatment has the lowest amount, which is 762 mg. The life cycle of a glass bottle includes raw material extraction, manufacturing, distribution, use and disposal. Greenhouse gas like CO2 and CH4 are produced during raw material production and manufacturing. Next, manufacturing use energy, especially during melting, which increase CO2 emission. Furthermore, transporting glass bottle adds to global warming due to fossil fuel use. Glass bottle produce little gas during use but can impact global warming during manufacturing and disposal, and improper disposal in landfills can release methane. Hence, evaluating the entire life cycle is necessary to understand environmental impact and find ways to improve sustainability.
In this study, we identify a few significant environmental impacts. The first is the production of glass bottle. It produce a lot of greenhouse gases, and other pollutants. It is because the burning process is too long in a high temperature to obtain a suitable glassy liquid to make it the glass bottle. Second impact is safety risk. It is because when it disposed of in landfill and ocean, it can cause injury to humans who are manage landfill and destruction of coral reef habitats and marine life. Last but not least, the use of bottles provides good benefits to the public in the industry, but even though they are made of natural materials, they still cannot decompose by themselves because glass bottles are non-biodegradable materials. Study, we define some of strategy how to improve the inventory analysis in the glass bottle manufacturing process. The first is we can improve the implement inventory management software, which is utilize the specialized inventory management software tolerate to needs of the glass bottle manufacturing. Second is the regular inventory audits. In this method, we can identify the discrepancies promptly and implement corrective action to prevent stock outs or excess inventory. The third is industry should organize the demand forecasting by using the historical data. It will reduce the demanding production of the glass bottle. And lastly, safety stock. Optimizing calculates and maintain optimal safety stock level to.
In the conclusion, despite its initial environmental impact, glass has significant benefit in terms of recyclability and durability. Glass can be recycled forever without losing quality, which reduce the demand for raw material extraction and energy usage as compared to fresh glass production. This closed-loop recycling technology drastically reduces trash and landfill use while promoting glass as a sustainable packaging and construction material. Furthermore, glass durability and innate nature make it a popular choice for application requiring long-term stability and resistance to chemical reaction, which improve its environmental credential over time.